Hey everyone, welcome to this webinar, part of our Mapbox Data Roundup series. Today we'll be talking about the Mapbox Movement data set and showing how you can do some analysis of people moving around in various different places with this data. So I'm joined today by Chris Byers, who's a product manager on the data team, and Fiona West, who's a software engineer. So yes, as they come on, say hello. I'll just kind of introduce things a little bit here and then hand it over to Chris. But for those who are dialing in and watching, we'd love to have you jump into the chat and get familiar with it. Let us know where you're tuning in from. Let us know, anything else you might be interested in sharing, like what you're gonna, what your interest is for this this movement data. But also just during the presentation, if you have questions, I'll be kind of relaying them. So go ahead and drop those in the chat and I'll relay them to the presenters. So you're probably already familiar with Mapbox. We're a location services platform, but data is the key word here, because we don't just do maps and navigation and search. We actually have data products that you can buy for any part of the world and various different resolutions and things like that. So that's what we're going to be covering today. Without further ado, I'm going to turn this over to Chris. So I'll stop presenting, and Chris, you can take it away.
All right, sounds good. I am going to try to keep my part short because we want to leave plenty of time for all the cool stuff that Fiona is going to go through. I'm Chris Byers. I'm the product manager for data here at Mapbox. And today we're going to introduce the movement data set to you. Our movement data set is a first-party data set of mobility data based on the telemetry that is collected from our folks using our apps and services, or using services in their apps, with around 700 million active users every month and around 20 billion location updates every day. We think of this as a privacy-first data set because we do a lot of work on the initial ingest to make sure that we strip any identifying information out of it, remove beginnings and endings of trips, and aggregate it such that we protect that end app user first and foremost. A lot of folks use our data for an analyzing site selection capability, so we can see where folks are congregating, where new roads are being built, doing risk analysis on various areas around the world. And our data is global in nature. So we have folks using our services all around the world, and as such, we have a global data set that we can provide. And the data itself is bend to 100-meter bends. We try to do that to protect the privacy of the end user again. But we can look at weekday versus weekend activities, daily activity on a driving level, or non-vehicle traffic, such as foot traffic, bicycles, unicycles, what have you. And this data is provided as a GeoJSON dump that you can license on an annual basis through Mapbox. And without further ado, I will turn it over to Fiona. If you have any other questions about the product itself, feel free to dump them into the chat.
All right, thanks, Chris. I am Fiona. I'm a software engineer on the movement dataset. Let me just get my screen sharing set up. Okay, cool. So I'm going to show you guys how to download a sample of our data, quickly visualize it so we can explore the data a bit and get an idea of what's in there, and then we'll go through an example of how you might analyze that data. So if you want to download a sample data set, the first place you can go is just mapbox.com. You can look through our products to the movement data product, which will give you some basic info, but you can go here to download sample data and basically just fill out a quick form. And from there, you'll be sent an email. It'll look something like this that just has a bunch of instructions and a link to the AWS public bucket where the data lives. So over here, we have this bucket. I'll come back out to the root here. We have a few different things in here, but our main data sets are here in version 0.2, and you can kind of click through. We have a few different countries. If we're looking at the US, for example, we have a few different data aggregations. We aggregate by admin area, but also quad key. Quad key is the most granular version of our data set. So we'll take a look at that today. For the public sample data set, we just offer the total activity, but we also break it down by driving and non-driving activity for our production data. And we have all of 2020 data for all of the countries that we offer in this public sample. So let's say, it's 2020. Let's say we want to look at how movement changed before and after the start of the COVID pandemic. We can click through here to January 1st. We have all of our data stored in CSVs partitioned by Z7 quad key. And if you guys haven't heard of quad keys before, they're basically a partition system designed by OpenStreetMap that divides the entire world up by zoom level.
Fiona, can I interrupt for just a moment and ask you to
Yeah.
zoom in a little bit if you can, because the resolution is a little small for the screen share. Thanks.
Yeah, I forgot about the resolution, sorry. But let me know if this works.
I think that looks better.
Okay. Let me just make this, okay. So we have this tool that I like to use a lot called What the Tile that kind of shows you what all the quad keys are and what areas they cover across the world. So since we're storing data at a zoom 7 quad key, let's say if I want to look at Chicago, I'll zoom in until it says zoom 7 here, and then I can just click to copy that quad key to my clipboard and come over here to paste it in. And that's just like the easiest way to immediately find which file your data's in if you want to look at a specific area. So you can download this. I already have them downloaded, so I won't repeat that. But let's say we want to look at January 1st and come back out again and look at April 1st, just for kicks. So we can download both of those data sets. And then the first thing I like to do when I'm looking at some new data is to just quickly visualize it. We do have Mapbox Studio where we can do a lot of visualization. And I really like using Mapbox Studio for creating more like in-depth maps. And I can show you guys a quick example of one actually that I made for a different demo. This is Seattle. This is, I loaded all of the data for one quad key for Seattle into a Mapbox tile set. And there's a few different layers, and it's kind of cool because you can do stuff like having the data aggregated at different zoom levels, and you can have a lot of control over the like the color scheme and how it looks basically. If you're trying to create a cool map to put into a web map, or you're trying to make a pretty map to visualize something, I like using Studio for that. But for really quick visualizations where you can just dump the data in and see it on a map, I like to use Kepler. This is an open source tool, and it's just kind of really bare bones and simple and does a lot of stuff for you. So it's easy to just kind of drag and drop and see your data. So I'm going to go to my downloads over here, and I can just drag these CSVs over here. And it's going to load up the data. I'm going to add my April CSV as well. It takes a second to get it all loaded because it's a lot of data, but once it's in here, it kind of just drops you off in the middle of nowhere first thing, because these are CSVs. So you actually have to tell it where to find the geospatial part of the data. So these are CSVs with latitudes and longitudes in them. So I'm going to tell it to map point data, and I have to tell it where my latitude and longitude columns are. You can turn on the fill color. Right now it's just a bunch of points. They're kind of like really thick points, so I'm gonna reduce the size of that. And then you can also color it based on a field. So I'm gonna color based on activity index. And so here's just like the fastest way to get a visualization of our data in front of you. And if you zoom in a little, especially because the points sometimes overlap with each other in this data format. But if you zoom in a bit, you have a pretty good visualization of all the activity happening over Chicago on January 1st of 2020. You can see there's a lot of activity happening in the central commercial area down in the loop. You can see a few things just by looking at this data, like there's a lot more activity happening on the north side, or a lot more activity density happening in the north side than the south and west sides. You can see a lot of these roads lighting up because that's where a lot of our activity occurs. You can kind of see the outline of highways and stuff. And one thing I'd like to call out is over here, this may take some context knowing where things are, but as someone from Chicago, I know this is the airport over here. This is O'Hare Airport. And you can see it just shows up as a big yellow blob because there's a ton of activity happening there basically every day. So we can do the same visualization for April. So I'm going to have to switch this to points, tell it where to find the data.
Fiona, can I interrupt again?
Mm-hmm.
Can I just ask you to zoom in a little bit on the UI so it becomes a little bit bigger? Can you do that like in the browser, like actually do a like Command plus in the browser?
Yeah, is this a little better?
Yes, that's much better. Perfect. Okay. Yeah, that's great.
Okay, sorry about that. All right, so now I have April set up. I can kind of switch over to the April data set. And the one caveat about using Kepler for really quick visualizations that I'll just point out is because it auto detects like the range of values in your data set, and it stretches your whole color scheme across that full range of values. So if we have a lot less activity happening in April, it's going to stretch the sort of red to yellow color scheme across a smaller range of values. So we see kind of a similar activity pattern in April that we see in January. But one thing we can do is going back to January, if we hover over some of these values in the loop, for example, we see a lot of the activity indices are over 1. And so just for reference, activity index is a relative measure of activity compared to actually January of 2020 in this data set. That's our sort of normalization period. So, and we base it off of a 1 in activity index. It should be the same as the 99.9th percentile of activity in January of 2020. So this just shows, this is some of the highest activity in the US happening in the middle of this commercial area. That makes a lot of sense. But if you compare to April, and you kind of look closer at what these activity indices are, we see that activity has, in a lot of cases, tanked by, 50% or more. Now we're getting indices of, 0.2, 0.5, stuff like that. So we can kind of just explore and see some of the impacts of the COVID pandemic just right off the bat from visualizing. We can also see if we look at that airport again, we have sort of like a sparser amount of data here. There's a lot more like reds and oranges mixed in, as opposed to this like really solid yellow blob that we had before. So let's say we want to investigate this a little more. Maybe we want to learn more about how activity dropped in airports in O'Hare, but also maybe across the country throughout the COVID pandemic, basically the course of 2020. We can move over to a Python notebook, and please let me know if this is zoomed in enough. to be visible. I'll just.
I think that's pretty good. Maybe one more zoom level. Just because I know the resolution might be different once this ends up on YouTube. Yeah, that looks great.
Okay, cool. So I have this whole notebook already prepped, and I'm not going to go through like line by line every line of code, but we can step through it to see an example analysis workflow and what that might look like. So first of all, I think I minimized the cell, sorry, but we import a bunch of libraries. There's just some libraries and imports and helper function in there. Just for reference, I like using pandas as something I reach for most often when I'm analyzing in our data set, because we can load all of our data into a data frame and then do a bunch of manipulations on it. We also use some geospatial libraries like Shapely, and we use a library called Mercantile to do conversions between quad keys and other types of geospatial data. So those are all super helpful if you're looking to do some Python analysis with our data set. So first off, I'm going to pull down a data set with just a bunch of metadata about airports throughout the US. And, here's an example of the information inside. We have, we're going to be looking at large airports primarily. So we have their name and their code over here, and we have the latitude and longitude of their centroid. So the first thing I want to do is basically create study areas for myself to look at. I'm going to keep things relatively simple and create just a buffer circle around each airport's centroid. If we wanted to be a lot more rigorous here, we could kind of like manually draw polygons around each airport building's footprint and use those as our study areas. And that would give you a really accurate measure of like all the activity happening in the airport. But I'm going to keep it simple for the purposes of the demo and just create these buffers. So first thing to do is convert these lat longs into a Shapely point. And so that's added to my data frame now. And then I have this function that projects those center points and creates a buffered circle around them. So if I apply that function, I now have these polygons, one for each airport in my data frame. And another thing we can do is actually plot those circles on top of like a mini Kepler map inside of the Python notebook, which is pretty fun. This is basically the same Kepler technology that I showed in the web browser before. But you can embed it here in the notebook. And so here I have Chicago as an example, and you can kind of see like a faint center point in the middle here. And then this is my buffered circle. It looks like, compared to the whole airport boundary, it looks maybe a bit smaller. But if we kind of come back in here and zoom in on the airport, this is the full airport boundary. And most of the activity is kind of happening in this central area where all the buildings are and the terminals and everything, just off of this highway that comes in here. So this ends up being actually a pretty good approximation of like where the main activity is happening in these airports. So now we want to grab all of the Z18 quad keys that overlap with our study areas. So here's where I use Mercantile to get those quad keys overlapping with these circle poly boundaries. And I can apply that to my airport's data frame again. And now I have an additional column showing which Z18 quad keys overlap with my circles. So now that I have that information, I can move over to actually dealing with our movement data set. We're going to want to download all of our data from the public bucket. Well, not all of our data. There's actually a ton of data in this bucket. So we want to make sure that we don't overload ourselves, especially working locally on a laptop. And you only want to download the data that you really need. So I put an example AWS CLI command up here. This is what I use to download the Chicago data specifically. So you can kind of sync the public sample data set bucket, but use these exclude and include parameters to get just a specific file for each day. So these are the day and month parts of the file path, and then just the Chicago Z7 quad key. And then what I would do from there is basically load up all of those CSVs into pandas data frames and concatenate those all together, and then filter down into just the Z18s that I have already found overlap with my study area. And that's kind of the final version of the data set for Chicago that I'm going to be working with. And all of that process, even working with a limited amount of data, it takes a while to download and load everything up. So I already prepped that ahead of time, and we're just going to go and load the data from that prepped file. And so this is what it looks like, the final data frame we have. Each row of our data has, a quad key, longitude and latitude. This is what we were plotting in Kepler before. The day from the 1st of January through end of December. And then we have our activity indices for each one. And this is just the Chicago data, but for this demo, we also have data for San Francisco, Denver, Dallas, Fort Worth, and Dulles. So I've already prepped those, and I'm just loading them all right now. All of that data is also located in our public bucket, by the way, as well as this notebook. So if anyone wanted to redo this, like step through this analysis at home, you can download all that data and get going pretty quickly and easily just using that. All right, so now we have all of our data. We can generate some statistics and analyze it. We're just going to be doing some pretty basic statistics here, just aggregating all of the data from all of the Z18 quad keys in each study area for each separate day. And then this function also does some different versions of that aggregation. So we are going to compute a 7-day rolling average of the activity, and also like a normalized version of the activity. And those will just help us understand our results a little bit better. So I'm going to apply that function to all 5 of the airports that I have already loaded. And then with that result data frame, I can plot the output, and here's the first basic result. So this is just the aggregated data, not the rolling average or the normalized version, but just the aggregated data for each airport over the course of 2020. So we can see some things right off the bat. All the airports start out with relatively stable activity. I say relatively because I know that it looks kind of spiky. There's a lot of variability. We see a lot of variability in our data over the course of a week, usually. There's kind of weekly patterns. You can see that best with, I think this is Dallas down here. You can see this weekly pattern. Sometimes, there's a lot of other stuff going on, I guess, at airports where you have huge spikes in activity and less activity on other days. But basically, all the airports have pretty stable activity for the first couple months of the year. And then they all tank right around the time that like major COVID shutdowns started happening in the middle of March. So this is sort of what we would expect to see. But it's kind of interesting to see like how massively they tanked, I guess. And you can see over time, they do recover a little bit, but not nearly as much activity as they had before the pandemic by the end of 2020. So if we want to look a little closer into this data, we can first look at that rolling average, rolling window average, and that kind of removes all that variability from just like the weekly pattern in activity. And you can see there's still some variability in some of the airports, but mostly they look pretty stable. And so you can just see that trend and drop and recovery a lot more in this version. And then if we want to compare the airports to each other, obviously O'Hare is the biggest airport out of these 5. So it kind of dominates this chart. So if we normalize the data to the very beginning, the January 1st data set, we can get a comparison of how these airports changed over time relative to their starting point. So in the rolling window version of this data, it's kind of so noisy, it's a little bit hard to see the differences between the airports. So if we go ahead to look at the rolling average version of this, we now get to a point where we can make some, take some insights and compare these airports to each other. So we have all of them pretty stable, like we saw before for the first couple of months. And they all have this giant drop and this small amount of recovery, but we can start to see like slight differences between them. For example, San Francisco started dropping at least a week before the other ones. That's kind of interesting. I'm not off the top of my head, I would say maybe like COVID was spiking a little bit earlier in California, and so things were shutting down a little bit earlier than maybe in the middle and east part of the country. You could definitely do some more in-depth analysis here by like pulling in public health data and like cross-referencing that with your data here and see if you can kind of see correlations and explain some of these patterns. You can see Chicago has probably the smallest amount of drop initially, but then Denver has the best recovery over time. So yeah, those are just kind of a few examples of some of the things that we can see by looking into our movement data, not just visually by dumping it in a map, but also with some honestly very short and simple analysis in a Python notebook. And there's definitely a lot more that you could do. We could pull in a bunch of other airports and look at them in aggregate. We could look at the difference between maybe international airports and smaller regional airports. And you could also apply the same kind of analysis to a lot of other types of locations, stuff like retail analysis, to see how commercial areas like the Loop, or even specific quad keys like Z18 quad keys, where maybe you have like a big box store and you're running like you're running a company that has big box stores, and you want to see how activity in those stores changed over the course of COVID, or how much it recovered, whether it recovered in certain parts of the country but not other parts of the country. You could look at where you might want to place new locations of your shop or whatever it is, based on where there's been the most post-COVID recovery or the most activity. You can see differences in seasonality for certain locations. You can see whether activity spikes, during the weekend or during weekdays for different areas, and make decisions about, your business plans based on that. And you can also do some analysis. We have some people that do analysis based on like public parks, for example, to see how much people are actually using different parks, and that helps them, like governments, allocate money to different parks and stuff like that. So yeah, just a little peek into what we can do with movement data. That's pretty much all I have for the demo. Are there any questions?
So there's a few in the chat. So I'll start with the latest one, but somebody asked about mobile India data for mobile movement. So do we have coverage in India? Is that something you can talk about?
Yeah, we do have coverage in India. We already produced that production data for some other customers. The one thing with India is we have a little bit less coverage than in places like the US. So generally we offer different data cuts of our data. So right now I'm showing you the daily 24-hour data cut. So that's basically, all the data for 24 hours condensed into one aggregate for each day of the year. That's our most granular version. And we don't generally offer that for India because of the limitation in the amount of data coming from that country. So we do offer like monthly aggregations. So that would be either every day of the week in 4-hour buckets, or you can get weekday versus weekend data in 1-hour buckets.
Awesome. And somebody asked earlier about, they said, can I ask about buffering in a similar way to roads? And I think that's because you were buffering around the airport earlier. Yeah. So is buffering around roads a thing?
Mm-hmm. Yeah, you could take any shape basically and buffer it, and use that as your study area if you want to see like what's the amount of activity happening along this one busy road or something like that. We actually have a version of our data set in beta that is currently not active but will be coming soon, where we basically match activity from our original data set onto the road network, and then we offer the entire road network like as the data format essentially. So on each segment of road, it'll have a certain activity index. So that's kind of like a not available yet, but if you're interested, you could hang around for that. Yeah.
Awesome. So there's one more that says, how would you go about creating animated maps from a time series of the movement data? So there's probably 100 ways to do that, but maybe you have an answer off the top of your head for the best way to do a quick animation.
Yeah, I know. I think there is a way to do it in Kepler. I am more of like a backend person, so I may not be the best source of like the front end applications of our data, but I know. I'm not sure how to do it in here, but I know I've seen, I think even like Chris had a GIF in his slides that showed an animation, and that was coming from Kepler. So I'd have to maybe like get back to you on that. But I know you can also create a web map with like a sliding scale. I've done that before, and you can just, the data set gets kind of heavy when you want to visualize like every day over the course of a year or something. So going back to my studio example, the use case for this was actually to put this tile set into a web map where I had all of the different time buckets for the day of week 4-hour version of our data set. And then there was a slider, and you could kind of manually slide it across to like see how it changes over the course of a week for a given month.
And is this, when we're looking at this right now, is this a raster layer, or is this vector? Like, is it a vector for each square that's on here?
It's a vector tile set. So this is one vector tile set with 3 different layers in it.
So yeah, depending on how large and robust the data is, you could definitely do like a client-side animation using set data, Mapbox GLJS, and just you would need to build in your own control mechanism.
Right.
But you could swap between multiple dates in the same data set. So lots of different ways to skin that cat.
Mm-hmm.
Okay, I think that'll wrap us up. Someone asked if we can show sample data of India, but I don't think that's something we can pull up quickly, right?
I mean, I could download. I could do the same Kepler visualization. Oh, I'm sorry, we don't actually have sample data. I thought we did, but
okay.
maybe this is updated.
So someone else just.
You can request a trial for India data if you do want to look at India.
Right. So the team will actually prepare like a sample for whatever area somebody's interested in as a trial. Is that correct?
Yeah.
Okay.
So if you want something other than just the public sample data we have, we can provide that.
Okay. So that answers the last question, which was, is there a way to preview the coverage for other countries? Basically, you'd have to contact the team and ask for a sample for whatever countries you're interested in.
Mm-hmm.
Okay. So I think that'll wrap us up. But like we mentioned, if you want to drop into the Discord, and if you have any other questions, you can either reach out to the team using that same form that was presented earlier to request sample data, or you can drop into the Discord, and maybe there'll be people in there who can help you with your general questions. So I think that'll wrap us up. Chris, anything else you want to cover before we sign off?
Nope, I think we're good. Everybody go take a look at the product page for Movement and check it out. See if you want to look at the sample data there and get in touch with us.
All right, excellent. Thank you all for joining us for this webinar, and we'll see you at the next one, and look forward to hearing from you if you're interested in doing more and learning more about Mapbox Movement data. All right, thanks a lot.